Tracking weather versus a climate. Some people confuse the two or use them interchangeably, but in all actuality, they are two very different ways that we track what we feel. Weather is a specific event. It happens over a short period of time. You might see that as a daily forecast, an hourly forecast, whereas climate is the average weather over a long period. 30 years of data is usually what is used as a benchmark to compile that type of data, but it can go over a series of decades, a series of centuries, what have you. Anyway, it's a much longer period of data. I love how somebody put this. Weather is how you would dress for the day. Climate is what you would have in your closet. So you can kind of see the difference of how those take shape. So how do we look at weather versus climate as meteorologists? Weather is something that, again, we would forecast an hourly, a daily, a weekly forecast. Things that we would use are tools like a 500 millibar height chart. We would look at how things are changing in the atmosphere over a certain series of days on a shorter term basis of how we would be impacted for the work week, the weekend forecast. Satellite and radar is another tool that we would use, again, on a short term basis. Weather patterns like the jet stream, our storm track, how are weather features in the atmosphere like high pressures and low pressures going to impact either a series of dry weather in the forecast or perhaps more stormy weather like a low pressure system that could in fact bring stormy weather as well. And how is the jet stream taking those different weather features into different regions and playing into those short-term forecasts? So that, again, is going to be more on the weather side of things. We look out to the Pacific, certainly, for some longer scale forecasts. But overall, these are going to be something that you would find out day to day what the forecast would look like. In the background of this, we do look at climate. If a weather model is forecasting 1.5 inches of rain in the month of June or July, when really Sacramento and the Central Valley just doesn't normally see that, that may cause us to look much, much deeper into why that might be happening. Could be a hurricane, like we certainly have seen move through Southern California and bring us higher precipitation in the month of August and even September. But all in all, those outliers are something that we would dig a little bit deeper into climate, or let's say a stretch of heat. Is this going to be a record setter? Have we ever seen heat like this? So we look at those monthly average temperatures, precipitation. Those are updated every 30 years. So we look at those 30-year averages, and then I should say these are 30-year averages. They're not updated every 30 years, but they're 30-year averages. So we're going to get regular updates to these to incorporate how we might be seeing our climate change over a period, again, of 30 years. One thing that could also be a factor in some of these bigger global situations are things like ENSO or El Nino, La Nina. That's when we have perhaps a wetter than average Southern California due to the weak trade winds. When we flip the switch and turn those stronger trade winds on, we see the cooler water in the equatorial Pacific moving its way off to the west. And what happens is, generally speaking, the opposite. We're going to get a drier than average typical Southern California, wetter than average Pacific Northwest through extreme Northern California. That is not always the case. But again, we look at some of those bigger global patterns. Now, that may be on a scale of year to year. Sometimes there's a cycle of some of these bigger decadal oscillations that will happen, decadal, every 10 years or so. So we look at those bigger shifts in perhaps the Pacific, the Atlantic. Those are things that are happening in the background of what may be playing into our weather pattern. Beyond that, we can go even bigger. Now, this is when we really start digging into climate. So often we exchange climate with climate change. But there is a very simple, so to speak, when I dissect this, you'll see it's a little bit bigger than just so simple, but it's the Köppen climate zones. And you can see how across the world there are many different zones. Tropical, dry, moist subtropical mid-latitude. We've got moist continental mid-latitude, polar, and then highlands. So those are going to be our 6 main zones. But then beyond that, we have a second letter and a third letter that comes in. So you take the first letter, A, B, C, D, E, and H, and you combine it with the second letter. That's going to be our precipitation patterns. And then the third letter, which is going to be the temperature patterns. Once we get that, then we start to get the more complicated subzones where you can see all the subcategories right here at the bottom of our screen. So here's the global map, many different beautiful contours up there, and then the subzones. Here's where California gets interesting. Take a look at this very detailed map. You can see that California has 11 different types of climate from the Köppen climate zones. Within that, we have the driest place in the U.S., Death Valley, and one of the wettest, which is going to be along the northwest coast, that receives almost 90 inches of rain a year. Our average California precipitation also illustrates this variability from north to south. You can see in the southeast corner here, extremely low precipitation numbers. We're talking on average 3 to 4 inches, if that, in some of the desert areas. And then we look at the northwest coast, and we're talking upwards of 50 to almost 100 inches of rain annually. Now, when you just look at the state, it seems impressive. But when you compare it to the rest of the country, it really stands out. Largest variability beyond any state. It doesn't even scratch the surface of precipitation variability. California definitely a standout when we talk about the variability year to year, season to season, as well as multiple years on track. Paleoclimate is also a way that we can monitor periods of drought or periods of wet years. We go all the way back to the 1800s, and you can see how we're kind of pivoted with drought and wetness here in a pretty steady fashion for periods of time. Now, there are certainly some standouts here, but here's where we are going to look at how we monitor periods of drought, periods of wetness. And when you start getting into the current, certainly the past 30 years or so, these droughts are far more extreme and longer than, say, the wet years. And so we've had a couple of periods in here where we've had some wetness, but you really see the stark difference in those drought years in the past about 30 to even 50 years in California. And so that's why water managers are trying to figure out a delicate situation, preparing for the wet years and the dry years as well. Now, our changing averages and changing extremes is not just a local situation. This is also on a global and even a nationwide issue. So you can see how the current climate is shifting to more of a warmer climate, which can hold more moisture. That could result in higher flooding issues as well. Bigger storm systems, that warmer air holding more moisture and producing those larger extremes. Our global temperature, also some of the warmest years that we've had on record have occurred in the past decade. So we've certainly seen this on a global scale as well. Statewide, nationwide, and then on the global scale. And that's just kind of how they mark these. So the 10 hottest U.S. years on record have been in the past decade or so. And then our seasonal warming also showing that even down to the city level. So there's so many ways to kind of layer how we're looking at climate, from what is expected from the type of temperate and precipitation areas that we're in, and how climate change is impacting what is already set in place. And seeing how that is influenced by climate change can also be looked at with the climate shift index. Let's say a given event, the hottest day on record. Was that influenced by climate change, and to what degree? So there's many layers that we can look at in terms of determining our weather versus climate when it comes to forecasting today and beyond.